Hey everyone, this is Aaron again. I just wanted to provide a correction or better explanation for the second application in my talk. And so here it is. The code that was used, as we see here, is really more like pseudocode. I've left out some pieces just to make it easier to look over. But I provide the full code with the talk on the Blackboard website. Anyways, here is our parameters that were used in the delta value as before. And as I said before, we have the exact value for the principal expectation of G computed at the bottom. You'll notice that it's made up of the two components that I discussed earlier in the talk. We have mu, which is the expected value of X, and then we have the exact value of the principal valued expectation of Y inverse. So that's the exact value. Now for the center part of the code here, what I did was I ran it 1,024 times. I like powers of 2 for some reason, and every time what I'm doing is I'm taking a sample of gamma difference random variables and a sample of uniform, and then the first line here is the estimate for the principal valued expectation of G using the first full Monte Carlo method, where I'm relying on both my sample of Y and my sample of U here. And then of course I'm multiplying this whole thing by mu, which is the expected value of X. This thing is my estimate for the principal valued expectation of Y inverse. And then the second line here, I'm doing the same thing, but I'm now using the series approximation, where I'm using the first 3 terms of that series expansion. And if I go to the next slide, I actually have the results this time. There they are. The first row is just presenting the exact value for PVG up to 4 decimal places, and the columns mean and variance here aren't really applied to this row. They're applied to the next 2, but there's its exact value. The second row presents the sample mean and sample variance of those 1,024 estimates using the first technique, what I'm calling full Monte Carlo technique. So based on 2 samples, I computed this thing, and as you can see, it does have a little bit of imaginary component left over because again, this is a complex random variable. The variance, however, is real, and which is based on that inner product definition. It will always be real and positive. The third line presents the series approach, the results, sample mean, sample variance. You'll see that the mean is actually in agreement to 4 decimal places of the first method, but it has substantially less variance for the parameters that were used, almost a quarter of the variance. So that illustrates the point I was making earlier about reducing the variance by evaluating that expectation with respect to U. And the last thing I put here is the relative error of the estimates based on the mean is less than 0.25%. And that is all I wanted to show for that. Thank you.